Now it's time to move on to the CAD software. In this case, we'll use Fusion, as I've already mentioned. This process will be divided into several phases. The first phase will be importing, which is a relatively simple process. The second phase will involve positioning the part in relation to the software's origin system. Alignment itself will also be done relative to this system. After that, I'll process the mesh, checking if there's anything that might still need cleaning or even mesh optimization. We'll discuss that, even if it's not strictly necessary. Only then will we move on to some explanations. I won't fully model this example. Instead, I'll explain how you can take a model like this and start reconstructing it with precision and using the tools available in this excellent software, Autodesk Fusion, for this type of operation. So, starting in Fusion, with a document already open, the fastest and most efficient way to import the model is through the Insert menu, specifically Insert Mesh. The model in question is this one. Here it is. Initially, you'll see this tool that allows you to define units as well as the orientation of the piece, but in a very rough manner. For instance, notice it rotates the part in 90-degree increments, which isn't precise enough for this case. Another thing to note is that the origin, currently available here, isn't visible, or rather it is visible below, and the model is slightly above it. By selecting Center, the origin or the model, it's unclear which one moves, will align. This is what I want. It's also possible to adjust the model relative to the ground using Move to Ground. As you can see here, the origin likely coincides with the model's lowest point, which is this area here. However, the model is still poorly oriented, so we'll accept this for now and proceed to align the model. The first thing I usually do is activate a sketch, possibly even hiding the model temporarily, as it can create some visual clutter. Often, I create rectangles like the ones you see here, roughly the size of the model, slightly larger or smaller. Precision isn't critical at this stage. I'll convert these to construction lines. At the moment, these rectangles are positioned on the XY plane. However, I also want to add a reference in the Z direction, so I'll open a new sketch. I'll close the first one and proceed in a similar way. Again, no need for fine adjustments. Once done, I'll hit Finish. Now we have a larger reference area, and you'll soon understand why this is important. I'll reactivate the imported model, and now we'll proceed with its alignment. Starting with this view, it doesn't matter which command you select for the movement. I'll use shortcut keys. The command I'm using is Move, and the shortcut is M. Despite using the Move command, I'm actually rotating the model. Notice that this part isn't perfectly aligned yet. There's a rotation here that I'll adjust and accept, which will register as a move in the timeline below. That's good practice. I'll make another rotation, approximately -1 degree. It's unnecessary to make very small adjustments at this stage since the model is still far from its correct position. I'll rotate it again. Notice how the lines I created earlier are useful. They help me position the model. Here, I'll make another rotation and lower the model slightly, trying to align this region, which isn't crucial as the entire jaw area here will be removed. After accepting this adjustment, you might notice a slight misalignment. It's much better now. I'll also position the object relative to the symmetry plane, approximately here. I'll verify its alignment from multiple angles. At this stage, I'd say the model is aligned. Now we can move on to the next phase. I'll remove this section. In this case, we don't have a tool like Trim, to cut the mesh. Instead, we'll use another tool. Under Mesh, Modify, and Plane Cut. We select the body and the plane for the cut. Notice that everything on one side of the plane, above or below, will be removed. Now it's done. Another thing to check is the dimensions. The model is imported, so let's measure it. I'll rotate it slightly, select an aligned point, and then the opposite point. The measurement is 101.7 millimeters, which can be rounded to 102 millimeters, roughly what we expected. Keep in mind that when refining the mesh, the dimension may slightly change due to the reduction of elements. Based on my experience, this rarely happens, and if it does, the change is negligible. Of course, it depends on the reduction's intensity. In summary, we began by importing the model into Fusion, proceeded to align it with the origin system, and made necessary adjustments to its orientation and dimensions. We also explored basic mesh processing, including cutting and preparing the model for further work. These steps form the foundation for extracting and reconstructing geometry with precision using Fusion's tools. This video is just the first in a series of 4. In the upcoming videos, we'll cover more advanced techniques to refine, optimize, and rebuild the model step by step.